Hello, and welcome to The Poor Man's Chemist. I am your host, the Poor Man himself, and in this video I will be demonstrating the synthesis of bismuth trioxide from bismuth metal. This will be the first in a series of videos called From Bismuth to Bismuthate, which details the synthesis of sodium or potassium bismuthate starting with bismuth metal. While bismuth itself is cheap and readily available, the alkali bismuthates are very much harder to come by for the home chemist. This is mostly because sodium and potassium bismuthate are very powerful oxidizers. For example, both salts can oxidize manganese dichloride to permanganate and chlorine gas in room temperature sulfuric acid. In fact, it converts almost any manganese salt to permanganate, and this was used as the basis of an older laboratory method to detect manganese salts present in a sample spectrophotometrically. Sodium bismuthate also played a role in the first industrial plutonium separation process developed during the Manhattan Project, known as the bismuth phosphate process. In this process, sodium bismuthate was used to oxidize plutonium after it had been dissolved in nitric acid. The bismuth phosphate process has since been replaced by the Purex process, which is now the standard method for plutonium extraction. Sodium bismuthate also has some utility in organic synthesis to carry out selective oxidations of certain types of organic compounds. One example of this is its use in the selective 1,2 cleavage of compounds containing an alcohol functional group directly adjacent to either another alcohol or carbonyl functional group without oxidation of any aldehydes which may have been produced in the process. And to top it all off, sodium bismuthate is one of the rare water-insoluble sodium salts. It is virtually insoluble in cold water and has limited solubility in hot water. This was the basis for an old gravimetric test used to determine the quantity of sodium ion in a solution. Although in professional labs this test has been superseded by superior technology, it is still a viable tool for the home chemist. Gotta be creative, people. This first video will show how to produce bismuth trioxide from bismuth metal. The second video will show how bromine is synthesized from alkali bromides. The third and final video will be the actual synthesis of sodium bismuthate from bismuth trioxide, bromine, and sodium hydroxide. I hope that you enjoy this little series of videos and that you find them educational. As always, I must urge you not to repeat what you are about to see because I really don't want to get sued. These videos are for educational purposes only. Alright, so first thing that we're going to do is we're going to take some bismuth metal. In this case, I've got a 39.63 gram chunk of very high purity bismuth. And I'll put it in here. And what I've got here is some 12 molar nitric acid. And all I'm going to do is add some nitric acid to the beaker, just enough to cover that piece of metal. And then I'm going to turn the heat on high, and I'm going to cover it up with this glass bowl on the top here. Put some ice in this so that as the nitrogen dioxide comes up with the water vapor, it will condense and drip back down as nitric acid. So your process will be a little more efficient, actually a lot more efficient. And so that's what we're doing here. So I'm going to go ahead and get started. Add the 12 molar nitric. And you can see that it's already off to a good start. Actually, I'm not even going to bother covering that completely. Now, obviously, I have not worked out the stoichiometry here. If you wish to, I mean, that'd be my guess. If I have a little bit of extra nitric acid, left over at the end, I'm not going to stress over that at all. It's really not a big deal. All right. I'm going to go ahead and grab some ice for the bowl now. And you can see here that our solution is a nice, beautiful green color. Look at that. Is that not absolutely gorgeous or what? It's like Christmas in June. So, we've got some ice in the bowl up there that will help condense the vapors and drip them back down. So again, so it'll be more efficient. And we're just going to let this run for a little while. Alright, so we are about 5 minutes into this, approximately. And you can see we're starting to get some condensation come back down. So that's a good thing. It's got this nice golden yellow color now. It's persisting. And the gas production has died down a little bit now. So again, that's why I've got the heat cranked all the way up to max at this point. And we will just let it keep going. Whenever the reaction seems to like really slow down or come to a halt, you just add a little bit more nitric acid and let it keep going until it's all completely dissolved. Alright, so as you can see, the color has become a bit more pale. The amount of gas being produced is a lot lower than it was. The heat is on full, and the reaction is going, but it's starting to slow down some. So I'm going to go ahead and add some more nitric acid. Oops, top off of the first here. Yeah, okay. There we go. Not breathing was the crucial part of that whole thing. Alright, while we've got it for a minute here, before the gas comes back, you can kind of see what's going on in there. Yep. Okay, so the bismuth is almost completely dissolved into the nitric acid, and because that's the case, I'm going to go ahead and take the top off of it. There we go, allow some of that gas to dissipate. Whew, boy, my God. Alright, that's better. So, we're moving on to our next step here, which is going to be to neutralize this with some solid sodium hydroxide. Obviously, this thing is boiling. Adding in sodium hydroxide, it is going to react extremely vigorously. This part is potentially very dangerous. So, another obligatory, don't try this at home. Alright, let's see. At this point, I'm going to turn on stirring here. I'm going to dilute this a little bit with some distilled water. And here we go. See, it forms the oxide very quickly. Whoa. All right. You see that the solution is getting so hot it boils every time I add more sodium hydroxide. Alright, we're starting to get there. Alright, at this point I'm going to go ahead and check the pH. This should be very alkaline. No, it is still very acid. Showing a pH of about 1 still. Let's see if you can see that. So, we're not there yet after all, but we are already getting a precipitate. Nope, still very acid. Not there yet. You can see we're getting a lot of boiling. This thing is very hot. And I think what I'm going to do is let this just stir for a little while and cool off before I keep going, because it keeps boiling and I'm worried that it's going to boil over one of these times. And that is the last of my bismuth, so I really don't want this to be a disaster. So we'll come back here after this has cooled off a bit. Alright, after the last shot, I went ahead and I added a little bit more sodium hydroxide to the mixture here and tested the pH, and this is what I got, which corresponds to, can you see that or not, about a 5. So we're approaching the point where we're going to cross from acid to alkaline here. Won't take much now. It is still very hot though. Let's see what that's got us. Okay, there we go. That is like a pH of 14 or something. Oh, I don't know, can you see it better there? There we go. Yeah, it's somewhere around 11, or 12 rather. So it is very alkaline. So that's good, that's all we need. Once the solution is alkaline, we just need it to stir for a little while and then filter off our bismuth oxide and we're done. Well, with this part of it anyway. Alright, I've had this stirring now for about 10 minutes, so I'm going to go ahead and turn that off, and then I'm going to get everything set up to filter off the bismuth oxide. But you guys can see what color it is. You can see that it is it's already starting to separate out. The moment I turn off the stirrer, it is so heavy. So filtering this stuff off should be pretty easy. Okay, so we've got our bismuth oxide, Bismuth Trioxide here, and it is ready to be dried. So I thought I would show y'all how I usually do this. Just take it out of here, out the filter paper with everything on it. Okay, it's still kind of wet here. We're just going to put it on here to let it absorb the water that's in here. Come on, Stirrer. There you go, buddy. Alright, so it doesn't take very long for this to soak all the way through, especially on the first one. So I'm going to go ahead and do a second one now. Suck even more water out of it. And of course, you do want to break it up some. It's kind of a thick, gooey paste. Kind of like wet clay. And there we go. Bismuth Trioxide. Synthesis is pretty easy and straightforward. I'm just going to go ahead and put this in a desiccator now so that it can dry out. But essentially, this one is done. So this concludes the first video in our series here, working up towards sodium bismuthate from bismuth metal. Now we've got the bismuth oxide. The next step will be to make the bromine, and then the last step we'll combine everything together and get our bismuthate. So very cool. Anyway, I hope you all enjoyed this. Please feel free to comment. I always enjoy hearing what y'all have to say. And we'll see you in the next video. Oh, here it goes. Here it goes. Yay. Look at the heat being given off by that crystallization process.